Hey everybody, welcome back. Today we are going to be doing an overview on some of the different storage options that we have in Google Cloud. Again, we're going to focus mainly in Google Cloud. It will be different in AWS and Azure. Azure in a more Microsoft's SQL Server-based environment. AWS, you're probably going like a Kafka, Cassandra type of route for their different storage options, or like their S3 instances, things of that nature. But what we're going to be looking at here are a few slides, and I'm going to be kind of zipping through them a bit. So if I kind of flip through some slides for you, don't worry too much. Basically, I'm kind of skipping over some things in between that we really don't need to go over. But at least for us, when we are trying to set up a storage solution, you really have to ask what your needs are and what you're planning on doing with that data. And the reason I mention that is because when we are trying to host information somewhere, you need the correct tool, you need the correct environment for that. And at least in Google Cloud, we have multiple options targeted at different storage types. So what you see here on this slide, and this is care of one of the Google Cloud programs. They've got some nice slides. You've probably seen screenshots on the blog at this point. But we have some various service options here. Now we have cloud storage, which I've got a few demos on. Basically, this is your file storage or file hosting for things that you need to serve, mainly, say, internal to Google Cloud. Basically files you would need services to interact with. Let's say you want to store spreadsheets or PDFs or scripts that are being sent up to Cloud Build and Cloud Run, things of that nature. Basically, it's just a kind of a storage bucket-based environment where we will host things. We also have larger types of storage options, more like data-centric. Cloud storage is going to be our file server, again, intended to work with Google Cloud Services. Then we get into the database level types of information management. So if you want a relational database, which should be similar to your MySQL, it's your MariaDB, again, SQL Server, things that are mainly tabular in nature, we could use Cloud SQL. We could use Cloud Spanner. The differences between the two are going to be mainly under the hood. Cloud Spanner is quite good at being very scalable. It's kind of a nice environment. Cloud SQL we'll probably take a look at as well. But kind of the key decision here is not necessarily which tool to use. We want to know, are we going relational or non-relational data? And that's what we're mainly talking about in this video. The other side is going to be the non-relational databases. And if you're not a database person, these terms might be new for you. If you are, please feel free to skip ahead, probably to the next video, honestly. But relational data is your tabular data. That's things that you can represent, say, on like an Excel spreadsheet. You're going to have a rigidly defined set of columns, and your rows are going to populate those fields. So think of it like you have, again, like a spreadsheet where you've got 3 columns. You might have an ID, you might have a name, you might have an email, password, 4 columns now. Basically, we're just kind of storing data entries. That's your relational data. If you want to go way, way, way deeper on that, get into database management, database theory, tons of classes for that here. But it's neither here nor there. That's the type of data we might need to store. And if we do, we'd pick one of these options. Non-relational, this is where we start getting into, it's more commonly used with, say, big data applications where you have different types of data, different amounts of data, data coming in at varying speeds. We'll get to that when we talk about big data later on. But these are non-relational at their core. And what that means is that we don't have an enforced schema. And what a schema is basically that rigorously defined set of columns. And to go in a little bit more detail there, columns can have, say, a data type. They can have specific attributes like, is it an auto-numbered thing for an ID? Is it a 50-character wide field? Is it a string? Is it a, heaven forbid, a blob object where you can store binary information? What kind of field is this? That's what you would get with a schema. If you don't have a schema, it's up to your application to enforce that, meaning that whatever program you're writing to interact with the database needs to enforce a standard. And the reason why you have to do that is you have to understand how to pull data out of it. In a non-relational database, it is generally very free-form. You could store things as, say, like a JSON object where you send in a little packet, or you could store it in a document-based format. You could store it in a graph-based format. It just kind of depends on your environment. But at least here, the options that we have, data store and bigtable, at their core, they're non-relational. So it's going to be up to you to define how data is structured, how it is accessed, how it is retrieved. If you're trying to liken this to other technologies that are out there, a lot of times you'll see applications like a Hadoop server or a Spark server kind of running on data stored in a NoSQL database. A lot of the big web applications out there, like in Amazon, like Google, not Google in general, but like more like the search engine or the Twitter feeds, Twitter friends, Twitter links, these are all going to be more NoSQL type data. And again, we'll get into what big data actually means. But relational versus non-relational is kind of your key starting point. We also have data warehousing, which if you are in kind of the more business-oriented side of things, you're probably aware of data warehousing. If you're not, basically you're looking to leverage massive amounts of data to make business decisions. And what data warehousing gets you is the ability to run analytics, the ability to run reports on your data and make, again, key decisions based on what you're seeing as a result of that data. Now, we will talk about BigQuery. This is going to be our big data environment. But if you're looking to liken it to something kind of more commonly thought of, this is your data warehousing solution. Now, in terms of cloud storage, we have some use cases, right? So I've been talking about the data types and what they look like, and we'll get into that momentarily. We care about being able to host information. So this first point, content storage, content delivery. Basically, are you hosting files? Are you hosting information? Are you providing it for later lookup? Use case number one. Think of a web server with a content farm where you're hosting photos or you're hosting videos. That is content storage. Okay, the second option is data analytics. So I am storing data, probably in a NoSQL or a data warehouse type solution, where it is stored in such a way that we can run analytics on it nicely and quickly. If you go into a more relational style database, their performance really starts to degrade. So you basically need a different solution for that. And with an analytics type environment, you're probably going to migrate towards a data warehouse type solution. Third option, we just want archival capabilities. We want our data to be stored for as long as possible in as safe of a manner as possible. Think of this like disaster recovery types of situations or restoration type situations. Basically, you want to be able to retrieve things later on. I think it's Amazon Glacier would be one type of archival solution where you might know that from, say, a home backup type of environment. Key idea for cloud storage is it is accessible elsewhere. Now, this is where I'm going to start skipping through slides pretty quickly because, again, some of this is boilerplate for other types of classes. We're focusing on the application side here. We just want to know what tool to use and how to deploy it, right? For us, at least in this Google ecosystem, we want to very easily be able to spin up databases, to access and work with our data, perform analytics if we need. And those tools that I showed you before here, these are all kind of intended to enable that for your particular use case, right? So now what we're going to get into is the different types of data. And this is going to fall mainly into the notion of a structured versus an unstructured data set. And I've got a nice written up post in the blog about that. And I guess nice is up to me because I think it's a beautiful post. But what does unstructured mean? What does structured mean? Here we have a nice tabular format. Here we have just some icons, which probably don't mean anything to you if you're looking at it right now, right? But structured data, tabular data, we have these nice rigidly defined columns. So we have a person's first name, last name, address, city, their age, whatever fields we need. We know exactly what has to go in there. Moreover, we know exactly what data type each of these fields are. We know what size they are. Are they allowed to be empty? And do we have extra meta attributes like are they auto-numbered? What's the character encoding? Everything we could possibly need to know. We can enforce that at the database level. So the database management system would basically enforce this schema, right? So this is our structured data. That's where it goes into something like Cloud SQL or Cloud Spanner. And again, we'll do demos on those, basically where we'll work with tabular data and we'll programmatically work with it. So that's our structured data. More often than not, this is going to be just fine for most common web applications, mobile applications, things where you're probably not expecting a lot of data, not expecting a lot of change, though that's kind of relative these days with the power of our database management systems. But this is kind of like an old friend, right? We know how to easily set up and manage a database server. And when I say we, I mean us as a industry, us as a domain. We can work with that pretty well. The unstructured stuff, this is kind of like the Wild West for us at this point, right? There are a lot of people and companies that understand NoSQL. And when I say NoSQL, this is not SQL, that's the acronym. Basically, we are not enforcing a schema, right? So in these cases, so we've got call centers, social media surveys, chat. Could you represent all of this structured in something like this? Yes, you could, right? With enough time and effort, you could do that. But with the speed at which these particular types of applications occur, and I'm talking like thousands to millions of transactions per second, since we're now in a cloud-based worldwide environment, structured data really starts to break down. Think of a social media type of application, a non-copyrighted Twitter. Is it going to be easier to represent this data structure as structured data? Say we have all our users or usernames, then maybe we have a foreign key to a list of their friends, which then references another foreign key. And how do we optimize that? We start indexing, we start creating views or stored procedures. You go down your standard 90s, 80s era style database lookup, right? Isn't it easier just to represent every person as an object with links to all of their friends and look it up that way? Maybe take some of that schema away and just allow every person or every user's object to self-manifest? And if we are just following links from person to person to person, couldn't we very easily build a feed for them? Absolutely, we can get some nice storage gains there. And again, I don't understand the exact notation under the hood for, say, a bird icon social media giant, but it's probably something similar to that, right? And you can look at these icons here and think of the type of data we're dealing with. Call center, voice transcriptions, we're probably dealing with recorded information, right? We're dealing with recordings. We might want to run analytics on that recording. Maybe want to get the person's emotions while they're talking to a call center worker. Anything we need to do. We can't just store that in a relational database. We can't store it in an unstructured database and maybe have links to, say, a recording up in cloud storage later on. Again, you could argue for or against either way. If you are the world's best database engineer, you're probably going to be able to run something just as fast as I'm describing with NoSQL because you know all the optimizations. But there is a lot to be said for unstructured data as well. So that's kind of the key idea. Is it structured? Are you enforcing a schema at the database level? Go structured, right? Go relational. If you have data coming in lightning fast, if you have uncertainty in your data sets, if the fields may change, if the data size may change, if you're dealing with petabytes of data, you're probably going to want to go NoSQL. Now, how do you pick a tool in the Google Cloud environment? This will hold for any cloud provider, by the way. You just have to replace the particular service that you're seeing here with whatever tool exists there. Is the data structured? No. Try cloud storage. Okay, and in this type of question, I know I mentioned structured versus unstructured. Here we're saying, is this like a file or is this something that we need to store as an object? Okay, so if it is structured in some way, go to the next step. Are we doing analytics? Yes. Okay, analytics again, let's try to make decisions based on this data. If we are dealing with a shopping application and we see somebody shopping for, say, volleyball nets and bathing suits and flip-flops and maybe we start recommending products that are geared towards the beach. Okay, this would be an analytic decision. We are trying to push products to them based on what they're already looking for. One type of business decision. Okay, do we need updates or low latency? Yes, do Bigtable. If no, do BigQuery. Okay, one is built very quickly for performance. The other one's built for data warehousing, analytics types, things where we can run a little bit more power behind the scenes. But maybe we're not doing analytics. Do we have relational data? No? Do data store. Yes. Cloud Spanner, if we need horizontal scalability, meaning that we can scale out our servers. If no, Cloud SQL, bare bones type of database management system. Again, I'm kind of glossing over a lot of the very particular details of these services. They are each built for a specific task with specific workloads in mind, but kind of a nice little rule of thumb to kind of guide you along the tool selection process. I think this is probably enough for one video. We'll continue on with what cloud storage means, the buckets. We'll talk about some of the different services that are out there, but until then, I'll see you next time. Bye, everybody.